Hi, welcome back to Mathline channel. Those who are watching must be knowing every week you can get a maths lesson. But those who are watching first time, I would like to tell watch all the previous lessons and continue watching. So we will start today's lesson. It is the continuation of the last class, that is we were explaining the properties of point, line, plane, and here I would like to give some more properties of point, line, and plane. See these figures. The first figure, there is a plane. This is the symbol for representing plane. This arrow must represent, it can extend all the sides, and we can see 3 points which are non-collinear, So according to the property, one and only one plane can consider three non-collinear points together, or three non-collinear points determine a single plane. Clear that if there are only 2 points, many planes you can consider in all directions. If there is one more point in the direction of A, only we can consider the plane. So what is the property? Three non-collinear points determine a single plane. Now come to the second figure. This is also similar to the first property. Instead of 2 points, we considered a line. So what is that property? A line and a point outside the line determine a single plane. Instead of this 2 point BC, we named as line BC. So line BC and the point A outside the line determine a single plane. It is somewhat same, these two properties. In this direction of the point A only you can consider a plane. So what is the property? A line and a point outside it determine a single plane. Now come to the next figure. In this figure you can see two intersecting lines in a plane. What is that property? Two intersecting lines determine a single plane. If the two lines are in the same plane, then only they will intersect. Clear? So what is the property? Two intersecting lines determine a single plane. Now come to the next figure. This is about the intersection of a plane and a line. These two cases of intersection. How intersection means common part. When a plane and a line intersects, what is the common part? See this. In this case, the line is not in the plane. Then their intersection is a point. The intersection of line and plane is a point P. When the line is not in the plane. Now this is the case when line is in the plane. When line is in the plane, their intersection is line itself, because all the points of the line are the points of the plane. So the common part is line itself. These are the two cases. For example, you can clear it. Suppose this is a plane, this is the line. If it is intersect like this, The intersection is a point. This is the line. If the line is in the plane, then the intersection is line itself. Clear? That is intersection of a line and a plane, the two cases. Now here, the intersection of two planes. What is the intersection of two planes? It is very clear that the intersection of two planes is a line. See, line AB is the intersection of these two planes in different direction. Different direction. So for this, one side of this consider as a plane and this is another plane. When they intersect, a line is formed. Clear? That is intersection of two planes is a line. Now, similar to collinear and non-collinear points, here coplanar and non-coplanar points. It is very easy to define from the planar, coplanar, collinear, like that. So here you can see a plane. In the plane there are many points, point A, B, C, D, E, etc. These points are said to be coplanar. Then what will be the definition? Similar to collinear, if all the given points are in a single plane, then they are called coplanar points. What are coplanar points? If all the given points are in a single plane, then they are called coplanar points. Now see this figure. Here different planes. It is represented using a rectangular box. Each side of the rectangular box represents each plane. So each plane there are points distributed. Point P in the upper face, point S in the lower face, point R in the side face, point Q in the other side face. All are in different plane. All these points are in different plane. So these point PQRS are said to be non-coplanar points. So what is the definition of non-coplanar points? If all the given points are not in a single plane, if all the given points are not in a single plane, then they are said to be non-coplanar points. For example, this is in this rectangular box. If one point is here, other point is here, other point is here, here, all in different points like this figure. So these points are said to be non-coplanar. Clear? These are the properties of point, line, plane. Now, understood? 3 non-collinear points determine a single plane. A line and a point outside it determine a single plane. 2 intersecting line determine a single plane. The intersection of a line and a point, line and a plane is a point here. When the line is not in the plane here, when the line is in the plane, then the intersection is the line itself. Intersection of two planes is a line. Coplanar if all the points are in a single plane. And non-coplanar if all the points are not in a single plane. These are the properties of point, line, plane. Now let me give one assignment. It is only for children. Mark 3 non-collinear points in your notebook. Draw lines passing through all the pairs of points. How many lines can be drawn? Do it and find the answer and write in the comment box. One more assignment. Mark 4 points such that no 3 of them are collinear. How many lines can be drawn passing through taking all the pairs of points? Find the answer, do the assignment, find the answer, and write the answer in the comment box. So, let me stop this lesson. Thank you for watching my lesson, and please share, forward, and subscribe the channel. See you next week. Have a nice day. Bye bye.